we know, of course this is problem number 1. Set 54 is my internal numbering system. You don't have to worry about what that means. But we have a pressure at a depth of 6.2 meters, and that pressure is 60,700 newtons per square meter, which could also be read 60,700 pascals. We want to find the force on a 3 by 5 meter rectangle at that depth. The definition of pressure is force divided by area. Pressure is a force per unit of area, the number of newtons per square meter, as indicated by the fact that we express the pressure in newtons per square meter. In order to get the force, we'll then multiply pressure times area, because if pressure is force divided by area, multiply both sides by area, we get force equals pressure times area, just doing the algebra. So we need to find the area. Well, the area is that of the 3 by 5 meter rectangle, which has an area of 15 square meters. So we multiply the 60,700 newton per square meter force by the 15 square meter area, and we get the total force 910,000 newtons. More generally, we can look at this figure. If we have a rectangular solid full of water, then the bottom of that solid has to support all the water in the solid. And the volume, of course, is equal to the product of the area of the base and the altitude of the rectangle. Volume is the altitude times the area of the base. Then the mass is going to be the density times the volume, which will be the density rho times h times a. So rho ah, which implies that the weight is, well, to get the weight, we multiply mass by the acceleration of gravity, so we get rho a gh. The pressure on area A, then, let's say the pressure exerted on the bottom of this water column has to exert a supporting force that's equal to the weight, because we assume that this mass of water here is stationary. So we have to support it by exerting a force equal to its weight, and that force will be rho a gh, which gives us a pressure of force divided by area, rho a gh over area, or just rho gh. So this is why the pressure at a depth h is rho gh.